Okay, in this lecture, we're going to, for your variables, we're going to construct and analyze a box plot. And for me, box plots are my favorite. I feel like there is a lot that you can do with it. Okay, a year of first Chick-fil-A expected to spend on a meal and a tolerable travel time. Those are going to be the ones that we're going to make a box plot with. You cannot make a box plot with qualitative variables. So let's come over here. I'm going to unhighlight these. No fill. Okay, so what year did you first eat Chick-fil-A? So we're going to do this one. How much would you expect to spend? So we'll do this one. And how many minutes are you willing to travel to get the fast food that you notice as your favorite? So we've got those right there. So we're going to, this is actually really easy. You just highlight all of your data. Okay. And we are going to insert, and you're going to see lots of different stuff up here. If you are a Mac user, there is a really decent chance that you're going to struggle with finding this. You should see something like this up on the top, but you might not. So if you don't see that up at the top, what I would suggest is looking online, seeing if you can find something that says, hey, this is where you should look, or just playing around with your charts. Sometimes you can, put a chart in and then, change it and so on and so forth. But right here, I'm going to click on this and I'm going to say, okay, I want this box plot. Okay. And you notice, okay, this is great. I've got a nice little box plot and it's already done. Okay. It makes it right there for me. And, I'm going to put in this information. I'm going to say the title is Year of First Year of Eating Chick-fil-A. Chick-fil-A. Okay, so we got that. And then I'm going to make this just a little bit bigger. Okay, and then I'm going to, let's see here, add chart element, and then I'm going to do data labels, and I'm going to say, okay, do I want it to the left? Do I want it to the right? Top, bottom? It really can be wherever it is that you want it to be. So let's go, I don't know, let's go to the top. That looks good. Top. For you, you've got to put it, like I said, wherever it's best. So I've got this wonderful information right here, and I am literally going to say, okay, I like this. Hold on. Click off of it, press Control X, and now I am going to Control V, and it's still tied right back to the original data. Okay? And so we can take a look at this and we can analyze it, and we can say, okay, the max, this is what I want you to do, is 2019. The, let's see, Q3 is 2010. The mean is 2007.266. That's good enough. I'm good with going to 3 decimals, and I'm going to give this a little bit more space. 2007.66. The median is 2006.5. Whoops. And then let's see here. Q1 is 2004, and then the min is 2000. 2000. So putting all of that information right there to the right is what I want you to do. And then also I want you to say, okay, if the mean is greater than the median, okay, I want you to comment on the skew. Then we can say it is positively skewed, right? Positively skewed. Because remember, when the mean is greater than the median, it's positively skewed. When the mean is less than the median, it's negatively skewed. Which normally holds true. So we're going to comment on the skew as well because we can interpret that. And outliers. Let's do this. Outliers above there are 0. And then outliers below, also 0. Okay, Control Z. So we've got the outlier information. We've got all that information right there. And yeah. So let's go back to clean data. So we've already got that one, and now we're going to highlight the next one. Okay, I'm going to highlight that entire variable. This variable is how much are you expecting to spend. And I'm going to do insert, box plot. Ooh, we have an outlier. Wonderful. So we've got an outlier. How much are you willing to spend? We're going to add chart element, data labels, bottom, top, what do we want? We'll stick with top again. And then chart label, willing to spend on meal. Okay, and I'm going to, once again, Control X, I cut it. I'm going to bring it right here. And then I'm going to put max is 12. And what I'm really saying there is it is the highest value. So instead of max in this particular case, let's do this. Highest value that is not an outlier. Okay, the highest value that is not an outlier is 12. Okay, then Q1 is 10, or sorry, Q3. Q3, the value of Q3 is 10. The mean is 8.36, which I don't know if you guys can see it or not. Let me see if I can. You can kind of zoom in a little bit and you can see, okay, right there, you've got the median right there. You've got the mean right there. So the mean is 8.36, which is that X, and the median is that line. Scrolling over to the left a little bit, we've got the mean, which is the X, and the median, which is that line. Okay, so I'm going to zoom back out. Okay, so we've got the mean of 8.4 or 8.36, kind of, there we go, 8.36, median of 8, Q1 of 7, and then the min, minimum, which is 3, which is not an outlier. And then outliers above. We have one outlier above, and the outlier above that we have is at the value 15. So I want you to put 1, and then I want you to put the information about it to the right, that the outlier that we have is at the value 15. And then outlier below, and we have 0 outliers below. And so we're going to do this just one last time. How many minutes are you willing to travel? And I'm going to go really fast. Okay. And I'm going to do insert, box plot. Ooh, we've got several outliers. Wonderful. So this one right here, what is this? We're going to get rid of, there we go. How many minutes are you willing to travel? So we're going to go right here, Control V. I'm going to travel time, add chart element, data labels, top, and then I'm going to just copy this just to save time. Control C, Control V. Highest value that's not an outlier is 30. Q3 is 19.25. Q1, or sorry, the median, or the mean is 14.1545. And I've got to figure something out. Let's see here. We've got the mean. Let's take a look at something really quick. Oh, we've got the mean right there. And notice we don't really see a line for the median. We got to figure out where the median is. Let's find out where the median is. Remember earlier, we calculated the median. Okay. Now, really funny thing, the median is actually the exact same. So we've got the median right here. We've got the median. The median is the exact same as Q1, which happens. Not super common, but it happens. So the median is the exact same as Q1. And then min, we've got the minimum, which is going to be 5. Then we've got 3 outliers above at 35, 45, and 60. 0 outliers below, and then skewness. The mean is definitely higher than the median. So because the mean is greater than the median, it's positively skewed. Okay. So, that's what we got right there. We've got all of these, and you can look a little bit deeper at these. But yeah, sometimes it doesn't always line up the way that you want it to. And remember, what we're talking about here, there is 25% between this line and this line. So between the minimum and Q1, there's 25%. Between the minimum and between Q1 and between Q1 and the mean, between Q1 and the median, there's 25%. So literally there is 25% of the data, more than 25% of the data is 10. Because the mean and the median are identical, which means that that gap, or that area of 25%, that area from Q2 or from Q1 all the way up to the median, the entirety of it is 10. And then so on and so forth. So there's 25% in this entire box then too, and then 25% of the data above this line. So 25%, 25%, 25%, 25%. So we're talking about locations there. Last but not least, we need to calculate the skewness and kurtosis. So I'm going to come over here, and we already have these fun little rows. We've got the mean, the median, the mode, the range, the variance, the standard deviation. What do you think I'm going to do? I'm going to go right here, and I'm going to do insert, and I'm going to do skewness, and I'm going to do kurtosis. And I'm going to say equals skew, returns the skew of distribution, and so we're going to highlight the entirety of our distribution. Press enter. Okay, so that again is just SKEW, and put that in parentheses, then highlight that, and so I'm gonna go like this, Control C. And what do you think I'm gonna do here? Equals KURT, give me the kurtosis. Okay, Control V. Okay, so I've got the skewness, I've got the kurtosis, and I am going to go, hey, just drag it on over. And for every one that it can, it will give me the skewness and the kurtosis. Now, I need to say something about the skewness and kurtosis. The skewness and kurtosis is one of those things where there's several different formulas to calculate this stuff. Okay, and technically this is rank. So we're going to delete that because you can't calculate the skewness and kurtosis for ordinal data. With skewness and kurtosis, there's several different ways to calculate this. But in general, as long as you have a decent amount of data, the skewness and kurtosis is going to generally come out the way it should. Okay, so what skewness and kurtosis does, if you have a skewness that is above +3 or below -3, then you know that your data is not normally distributed. And if you have a kurtosis above +3 or below -3, you also know that it is not normally distributed. There's some people that say 2, there's some people that say 1. The thresholds that I would use personally is if skewness, okay, and I'll write this down, if skewness is below negative 1 or above positive 1, it is slightly skewed. Okay, and then if it's above, Control C, Control V, is below negative 3 or above positive 3, then it is significantly skewed. Other people would say 1.98. It's a little complicated, but we'll go with 1 is slightly, and then if you wanted to, Control X, slightly. Significantly. Let's do Control C, Control V. Negative 2 and positive 2. We're going to do moderately skewed. So it kind of gives you some words to put with it. So when you're dealing with 1, it's going to be slightly. 2 is going to be moderate. 3 is going to be significantly. Okay, so that's plus or minus, plus or minus, plus or minus. So if it's beyond that. Okay, so this right here, skewness, it is definitely above positive 3. So that means that this is going to be positively skewed, which means that the data is not going to be normally distributed. What does positively skewed mean? I'm going to borrow something from Laird's statistics here. This right here is positively skewed. It is, you've got your data, it's really heavy on the left end, and it's skewing towards the positive. Okay, this one's negatively skewed, really heavy on the right end or on the upper end, and skewing towards the negative. Okay, and then next we're going to look at what kurtosis is. Okay, kurtosis is when data is very highly concentrated in the center. And so you've got a very tall distribution. So this right here means that the data is very tightly, the data is very tightly compact, right? But it is also skewed in the positive direction. I actually kind of want to look at this a little bit. Let's do this, and we're going to do insert histogram. And so you'll see, okay, yeah, that's exactly right. We've got this data right here, and it's skewed in a particular, here, I'm going to Control X. I'm going to bring it up here, right next to this, and you're going to see you've got some responses that are down here, just like a couple, okay? And then all the rest of them are right here. And so you've got all of this data that's all the way over here, and because the data that's all the way over here is really messing everything up, you've got this really tightly compact data right here, and just a little bit of data over here that's an outlier. So if we were to actually sort largest to smallest, and we were to get rid of the ones that are outliers, you see how it changes everything? The skewness changes, the kurtosis changes. Because of those three items, it changes everything. Let's see, the kurtosis is still a little high, and you could even, if we were to get rid of a few more, all of a sudden we got rid of those 5 people, or those 6 people that took a really long time, and as soon as we got rid of those 5 people that took a really long time, it changed everything. And so if we were to go back in there and we'd be like, hey, you know what, we understand that these 6 people took a really long time. What we're going to do is we are going to remove them from this data set. We are going to say these 6 people are the ones who started the survey, left, and came back, and we have documentation saying that they started it, left, and came back. Now, only do that if you actually do have that documentation. If not, guess what? We're going to leave it exactly the way it is, and we're going to say duration, or time to take the survey. Okay. So let's go down here. So that's skewness and kurtosis. Kurtosis, it's a very high, very highly, or very compact and very high. Okay, so, and once again with kurtosis, kurtosis is probably a little bit different. Let's do this. Control C. For kurtosis, we're going to do 2, 3, and 4. There's a lot of debate about this. Some people would go 2, 4, and 5. It basically, if it goes above 2, that's when you need to start being concerned about kurtosis. That's when you need to be concerned about being too highly compact. Okay, so coming down here, what year? We've got the kurtosis is right here. It's not too highly compacted. So we'll do this. We'll insert a histogram. Insert, so that way you can see it. Control X. I'm going to move it up here. And so what we have here is we've got this data that's, fairly, normally, well, it's not really normally distributed at all, but it's not skewed, and it is not what would be leptokurtic. And if it's too small, it would be platykurtic. Like, if it's really far spread out and it's just really flat, platykurtic, it's like it's flat. Flat. Leptokurtic, it's like you're leaping. And so that's what you're looking at there. And then right here, same thing. Here, I'll show you the distribution. Insert, and I'm going to make there we go. And you'll notice it's not too flat. It's not too, hold on. It's freezing, sorry. It's not too flat. It's not too skewed, left or to the right. It's not necessarily normally distributed. But then let's take a look at this last one. And this last one is going to be a little bit leptokurtic, means that it's going to be a little bit compact in one area based on what I saw up there. And you'll notice right there in the middle, here, I'll move it up here. Right there in the middle, it is a little high in the middle. So the leptokurtic, it is a little leptokurtic, which isn't going to hurt us too bad. Being leptokurtic isn't something that we are as concerned about as it being skewed, but you can also tell it is skewed. It's positively skewed. It's skewing towards the positive is what it's doing. And so we've got positively skewed, negatively skewed. We've got positively skewed here. We really don't have too much negatively skewed data. So what I'm going to do is I'm going to just copy these, Control C. These are the ones that I care about. Unit 1, Week 4. I'm going to come down here, and I'm going to post just the values. I'm going to put skew, and I'm going to put skewness, and I'm going to put kurtosis. And then, just like what I was telling you about earlier, I want you to interpret each one of these. I want you to say, hey, it's positively skewed, it's negatively skewed, and I want you to say, basically just based on these thresholds, just based on those thresholds right there, is it positively skewed, is it negatively skewed, is it slightly, moderately, or significantly, so on and so forth. So please do that and submit those. If you want to, you can put these charts next to it. I just think that it was a really good visual representation, so that way we could look at it. You don't have to do the charts. I was really just doing it for a visual for you. Other than that, I think that's pretty much it. That's the entirety of the Unit 1 project. So, make sure that you've got down here for 3, Control C, Control V. Put your skewness, if this is going to help you. Let's see here. Let's do this. Delete. And then give it a little bit of space. Control X. Control X. And then put your interpretation. Interpretation. And then we'll do Control C. And then what we're going to do is we're going to say, what is this? How many minutes are you willing to travel? The amount of time individuals are willing to travel is moderately skewed. Or a better way to put it is the distribution of the amount of time. Because what we're talking about there is we're talking about how is this distributed, right? So, how is it spread out? The distribution of the amount of time individuals are willing to travel is significantly leptokurtic. Okay. Or significantly leptokurtic. And if this was negative, then it would be significantly platykurtic or significantly flat. And so do the same right here. Right here, it's the distribution is not skewed. The distribution is not is not leptokurtic or platykurtic. And then same thing right here. And then that's all that you've got to do for that. And that's a big assumption. We know that we can start working with the data when it's not too leptokurtic, it's not too platykurtic, when it's not skewed to the left or to the right. That's when we know that we can start using the data for what it's supposed to be. So that's pretty much the long and short of that. Hopefully this went a little bit faster for you. Then definitely week two is definitely the hardest. Thanks so much for working through all of this, and hope this was a beneficial experience. Looking forward to Unit 2 project.